We're going to try something very dynamic, very exciting, and in real time and in live, we're going to take a novice fencer, and we won't make them Olympic caliber, but hopefully we'll improve them along the way. We'll just do sort of a series of introductions. So Rob Hupp, former fencing coach here at MIT, now retired, but now working with us in the Immersion Lab, research staff here at the Immersion Lab, really interested in how we use AR and VR technologies to coach. But Rob, let me have you introduce yourself and then introduce your pupil, and we'll take it away here. And we want to feel free, again, the audience ask questions. We'll try to field them. We want to make this as dynamic and interactive as possible. So, yeah.
Hi, my name is Rob. As Brian has said, former fencing coach for one of the weapons here at MIT's varsity fencing program, now research staff here at Immersion Lab. And this project came from initially some interest between myself and the head coach about taking some homegrown sensors and trying to do some analysis of fencers for assisting in our coaching, and also for preparing some of our advanced fencers for more elite competition. That morphed very quickly after learning about Immersion Lab to proposing a project, and now we are in the midst of that project that's split into 3 different levels. This is Charlie, who is our light technician and has been volunteered to try out this immersive technology. He is going to be in what we call Tier 1, in other words, novices who are learning how to fence, and we're comparing modalities of 2D high-resolution video, VR, and AR. And I think what we'll do is, without going into excruciating detail at this point, we'll have you see what Charlie is seeing. And I'll narrate from the side.
Charlie, you can talk.
Okay, yes. So I'm seeing what's right in front of me right
so
now.
That's what we call the pass-through mode. I
Yes.
think Carlos is working on putting up a 2D canvas, if you look around.
Okay.
So pass-through is when we have a subject seeing the environment they're in. They're not getting any sort of feed at
Hi,
all. We use this for kind of a testing mode. After they've had different instructional modes, they go into what we call pass-through, and we see how well they've picked stuff up. And you can also, I think you're seeing the screen, what you're seeing is the camera watching Charlie's eyes. This headset has inward and outward looking cameras. We can do gaze tracking through this, pupillometry through this, and then also he is able to see the environment he's in, but he's not seeing it directly as in through a transparent screen. He's seeing what the inward pointing camera shows.
It feels very real.
It is very real.
Describe the data part.
Okay. Do we have a feed of the data?
So we'll put up a feed of the data. Yeah. Move around.
Yeah. You can move around. You can jump up and down a bit. The camera is probably still focused on Charlie a bit. So what you're seeing is we'll have you freeze for a second. We're seeing infrared reflective markers here on his clothing. We're also seeing infrared reflective tape on the weapon. And this is being captured by the OptiTrack system around. He's also got what we call FSR sensors in his shoes that are measuring the impact on the floor. Now, in full experimental mode, we'll also have EMG sensors on his body looking at muscle activation, also acceleration of the different parts of the body.
Let's do a little demo on the FSRs.
Okay. Do we have
things-
data feed?
Yeah, there's a data feed of the FSR. That's what.
Okay. All right. So jump up and down a bit. Now alternate your feet. Stomp like you're stomping around. And what we can see is the different foot motion. Also, the FSRs are keyed to different parts of his foot. This is important because we learn about the balance of the actions by the weight transfer across the different parts of the foot, not just the individual feet themselves. And on top of that, we have the actual motion of the parts of the body and the motion of the weapon. And these are all synced. So at any given time, what Charlie is seeing, we know because we've created that avatar. Where he's looking, we pick that up through the headset. And how he's moving in relation to that, we measure. So all this data, which is, in Charlie's case, is a reasonable amount, but when we do a full experimental capture is an extreme amount with 100 markers on his body and 40 sensors, we have a tremendous amount of data to analyze.
So why don't we do a little demonstration of how
Excellent.
it would work traditionally?
All right.
So Charlie would be looking at you,
Okay.
and you would
Okay.
be bringing Charlie through a specific motion. The audience can see what Charlie is
Well,
doing.
right now I don't see anything.
That's fine. You're just going to see.
Okay.
You
the-
see me?
No, I see nothing.
Oh.
Oh, now a check mark.
Can you see me?
No,
Not yet.
Can you
not yet. I think it did some focusing thing, like it's restarting.
Okay, there.
Okay.
We are going to replicate the traditional.
I'm going to take his headset off so he can actually see me.
Hello.
All right, so I'm going to guide you through as if I was teaching a PE class.
Okay.
So you're going to put your heels together at right angles. Now you're a right-hander, you're holding a weapon in your right hand. All right, so you're going to take a step that's about the width of your shoulders forward. So that's good. All right, now, I want you to hold your hand as if you're holding your cell phone. No, not up by your ear, but where you might look at it.
Okay.
Now, let your friend see it over your shoulder. Not quite that big. There we go, like that.
Okay.
All right, now this is getting boring, so you're going to kind of slump a little bit. And you can put your hand on a fence post. All right, and slump a little more. There you go. Now you're in what we call on guard position, like so. All right, now you're going to take a step forward. That's it. Good, and again. Now I'm going to caution you about one thing. Your knee and your toe want to point in the same direction. We don't want to mess up your knees.
Okay.
All right, now you're still going to push off your back foot, which is good. You're going to take a small step forward. Now I want you to take a little hop. Boom, hop forward. Boom. Okay, now take a small step back. Okay, if you're going to move, what we tell people is you're going to push with your trailing foot. So you're going to move forward, your trailing foot's your back foot. You're going to move backwards, your trailing foot's your front, so push with your back step, front step with your back. That's it. Excellent. Again. Good. All right. Now, from that position, without moving your back foot, you're going to think of hitting somebody. And I want you to think of this is you're getting out of your chair, and you don't want to, you're being kind of lazy. So what you're going to do is you're going to put a Post-it note on the wall with this, and you're going to take a long half step. Half step.
A half step.
Yeah. Boom, half step. That's it. You're going to put the Post-it note on the wall. There we go. Okay, and now for balance, your back hand's going to go out as your front hand goes out. So there. That's how I would traditionally teach the beginning footwork. All right, now we'll have you back up a bit. Just walk back a bit. All right, now you know the small full step. Do that. Now make a little hop. Now make the long half step. Boom. All right, good. Now go back. Now I want you to put one after the other. Small step, jump, half step. All right, you have just done what's called an advanced jump lunge.
Oh.
All right, and normally you would use that action to hit your opponent. So I'm going to guide your tip just so you feel it. Get on guard again, and we're going to do advanced jump lunge. Ready? You start when I pull. Boom. Yeah, and you would be hitting your opponent like that. So that's how I would teach it if I were actually in a fencing room or in a gym class. This is what I would show you. And you've just covered what I cover in sessions 1 and 2.
Oh.
It's very easy to teach one person. Well, I won't say it's easy. It's efficient to teach one person. It goes quite quickly. You're teaching 14 or 16 people. You want an even number. It becomes a little more difficult. So, do we have our headset ready? Not too sure yet. All right.
So why don't we explain why we are using this headset? compare traditional coaching to what we are trying to achieve here?
Well, we can obviously teach quite efficiently when we don't use the headset. What we cannot see sometimes are essentially what I would call under the hood. I'll give an example, and this is on a higher level. So when we're creating the avatar from which Charlie is going to learn, this is a student of mine who's a student of long standing and has a tendency to do an action and tighten up their shoulder. Now, when a student is taking a high-level lesson, very often they're in full fencing gear. You can't really see their body mechanics. But regardless, person is tightening their shoulder, say, relax your shoulder, tighten the shoulder. The traditional view would be there is tension in the upper part of the back and the neck, and this is making the person respond this way. Once we did full instrumentation and we captured the motion and then we also captured the muscle activation, what was immediately apparent was that this was not coming from where we would traditionally think the tension should be, which is up here, but was actually caused by a muscle imbalance in the upper core. And as the student was making this action, the upper core was collapsing and the shoulder was moving in compensation. So I, as a coach, could have said, as I'd said for a year, stop tightening up your shoulder. Instead, what I'm now able to say is, strengthen the upper core, because when we condition people, we tend to concentrate on the lower core. I was then able to use this with the varsity athletes and say, I think you need to be careful of the fact that you are not strengthening this part of the body. That then pushes back and says, all right, we tend to be what a therapist once said, American desk posture. We kind of hunch forward, that weakens here, we tighten the shoulders, and then we have problems in athletics based on our day-to-day activity. We could not have seen that without this kind of instrumentation.
So in terms of immersive athlete training, let's talk about how we are mimicking a more traditional one with a 2D video screen as a control. So that's the first thing we're going to see.
Okay.
And the audience is going to get, in a moment, a first-person view of what Charlie is seeing, and also a view of Charlie.
So what you're seeing now on the screen in front of you is the 2D presentation that Charlie is seeing. This is actually the fencer who is creating the avatar. And this is, if you are a person who studies YouTube to learn things, this is a traditional view in which you would try and learn the sport. Now, one thing that's very obvious is you are watching a human body, and we are conditioned to watch human bodies. You can also see from this perspective that the avatar model is showing Charlie exactly the footwork that I ask him to do. From this perspective, it's very clear what's happening. It's important to understand that because the only feedback that Charlie is getting is visual. There is no auditory feedback yet. And Charlie is now imitating what he's seeing on screen. And doing well, I might add.
First
And
time.
we're also seeing what Charlie is looking at. We're seeing the motion of his eyes. And this is important because it gives us information about what a student is looking at. How are we learning? What is the target for his gaze? Now we've gone into a VR avatar that
Let's
was...
hear from Charlie. What
All right.
Wow. I'm in another world now, and there's an avatar my size doing just what was on that screen a moment ago.
Now, one thing that you can see what Charlie sees. Notice that there's a little bit of a difference. What can't Charlie see from real life? Charlie can't see his own floor.
Oh yes, I can't see my floor or my feet, but I see this avatar on a platform.
Yes, there's a plinth that the avatar is moving on, and this was done to raise the accessibility of watching the avatar's footwork. And you can also see the gaze path that Charlie is doing. This is one of the things we wish to study. I'm going to move Charlie over a bit, so
Okay.
otherwise he's going to stab the computer.
Okay.
There you go.
All right.
All right.
So
All right, now you can copy from that.
Oh.
Now, one thing that's not implemented as yet is the ability for us to take Charlie's motion, his motion capture, and
forgot
map
to
it
jump.
onto a generic avatar that moves at the same time as the training avatar. So that this would give Charlie biofeedback on what he's doing. Yep. All right, now we'll give him a break.
Oh.
Ah, there we go. Now we have the avatar in the room. Charlie can see. Charlie can see the real thing. He can see the room. So this should affect his balance.
Okay.
What we saw before when he's in total VR would be essentially saying, do this motion with your eyes shut. Do it from memory. Or walk across your living room with your eyes shut. You don't have a sense of where you are. We are a visual species. We tend to take our balance more from vision than from vestibular input, which is an area that we want to study after this. And so now Charlie can copy the avatar in his actual environment. How does this affect where Charlie looks? How does this affect Charlie's footwork? We can pick up his balance based on the motion of his body, but then also the FSR input from his shoes. In other tests, we've found that people who, once they're comfortable with this and they really extend their reach, if they're not in balance, they have a very, very singular kind of foot strike, as opposed to people who are in balance.
Now, can you talk a little bit about what we are learning by looking at Charlie's movements in these different environments?
What we're picking up is, and we have to understand that this is kind of an absence of
again?
immediate biofeedback. When I'm working with a live Charlie, Charlie's working with a live coach, I can provide immediate biofeedback. We would like to extend this so that there is, as I mentioned, a companion avatar that shows Charlie what he's doing. What we're able to do then is we're able to study, is Charlie propelling his body forward in what I, as a coach, would consider the best possible means to do so? In other words, if he's moving forward, he should be driving off his back foot in all cases. If he's watching the avatar in terms of, let's say Charlie now wants to move in a sort of opponent coach mode, where should he watch on the avatar to determine whether he should move forward or backward? That's not implemented here, but it is a plan to implement. If I tell Charlie, watch the avatar's hand, he's going to react in one way, and not necessarily the best way. If we say to Charlie, watch the avatar's feet, he is going to then do something different. He's going to watch the feet, but this is not necessarily going to help him control his motion.
See the
Ideally,
avatar
when you
more.
watch an opponent in fencing, you want to take into account the feet and the hand, but it's the core that's connected to both of these. If the core moves, in other words, the front hip, which is the front projection
Avatar's
of your
right in
core,
front of you now.
if this moves, then everything's coming with it. So we want to teach someone how to fence. We want them to look at the right thing so that when they're fencing a real person, they respond properly. So we can pick this gaze up. Then we can also see, based on the gaze, is he starting to move properly? Is he leading, for example, oh, I want to move backwards. Do I start throwing my shoulders back, which makes moving backwards quite difficult? If I want to move forward, do I start with my shoulders versus my core? Again, I start with my shoulders. This makes moving forward quite difficult because this transfers weight onto the front or back foot inappropriately. So we can pick this up on a very, very granular level. This will allow us as coaches to maybe modify what we teach. Should we say, be very conscious of dropping your shoulders when you move forward, for example? Should we say exhale when you move forward, because that increases concentration on the core?
So we have 2 minutes left.
Okay.
Why don't we give the audience a sense of what something to appreciate on the FSR. So so we do just in advance, show them what that looks like.
Yep.
Yeah. So Charlie.
Yes.
So just do a few advances. You're just walking.
Okay.
Yeah.
Can I face the other way?
Yeah. You can face whichever way you want.
Okay.
The
I'm
other
gonna
thing we
face
could
this
do,
way.
have you do is do some jumping jacks.
Okay.
So take a couple of steps forward, and that's what the pattern of force under the feet looks like. The audience can pay attention to the right side of their screen.
I lost my view.
No, that's great.
Oh, okay.
I'm just coaching you to the moves you
Yep.
already done.
Okay.
Can we also show ray tracing?
Let's show, so they can see the trajectory.
Okay.
So let's do a few lunges. So what
Okay.
happens if you stomp on your front foot? So take a bigger step forward and stomp. So that's a different pattern.
Yep. Now, I'd like you to lunge like you were doing before.
Uh-huh.
So you're going to drop your point. No, drop as if you're putting a Post-it note on the
Oh,
wall.
oh yeah, like
And
this.
then make your long half step forward. Drop your tip. Now hold that. All right, now what I'd like you to do, let's watch the FSR, is I'd like you to lean forward and raise your heel.
Lean forward and raise my heel.
Yep, and so what we can see is we actually see a transfer of his momentum forward. He's not in control of it. He's shifted his weight onto the ball of his foot, raised his heel, and what this says is he's off balance. And he's more likely to end up in a position like this, which is not good fencing for him, and biomechanically poor, but also can lead him to injury if he does it enough times.
Exactly. So the data can give us insight into how can help you drive coaching depending on showing how prone they are to injuries.
Yes.
So I think that's good for the demo.
Yeah, and then we can talk a little more about how we extend this further.
No, definitely sort of thank Charlie. Sort of wonderful. You're on your way to the an Olympic fencer, hopefully, and Rob and Praneeth. So maybe just a final parting comment on how you hope to deploy this more broadly in fencing.
Well, in fencing, what we're hoping to do is, and the initial thrust of this was, no pun intended, to take advanced level athletes
Is that all right?
and construct an elite level avatar. Now, in order to do that, we need this high level data.
Okay.
And we would use this elite level avatar, slowly increasing its speed, and do what's called stress inoculation. And this stress inoculation has a long history in what I guess you call high-speed professions. Smoke jumping, law enforcement, special forces, EMT, emergency room, that kind of thing. And you try and get people inoculated to what is a stressful environment. When an advanced fencer fences an elite fencer, the elite fencer is so far above. And if they don't have a chance to fence elite fencers on a regular basis, they can never train to meet this.
Right, so it gives an exciting way to sort of bring somebody along on the journey where you work them up to sort of fencing at the elite level.
Exactly, but we can also then look at what breaks them. We have gaze tracking. We can see, is there a particular combination of moves? Is there a certain tempo? And then looking at the athlete who's also instrumented, what is it that's breaking down?
Awesome.
Is there a coordination that's falling apart? And then I have one last thing.
Please do. One last thing, and we'll take it to the student after that.
And I think this is looking out into kind of a broader spectrum. We want to then do elite level athletes looking at elite level avatar. The elite level athlete will monitor them, but what we would also like to do is put some EEG sensors on them and have them motionless. We'll put the EMG sensors, which weren't demonstrated, on the body because there is information that's downloaded toward the muscles. There's a preload. We'll show them an avatar. We'll look at their gaze. And what we'd like to see is pre-verbal brain activity saying, now is when I should go.
Awesome.
What is it that's triggering that? And that has not been studied yet.
And it's all enabled by ambient sensing.
Exactly.
So Rob, thank you very much. Charlie, thank you. Praneeth, thank you. We'll turn it over to our next student presentation, and then we'll take a short break, and then we'll come back for our second session.